Hey, good evening, everyone. Ansh this side, and today we have to discuss our next topic. And these are the today's agenda: introduction of to query optimization, how query optimizer works, optimizer components and operations, who influences the optimizer, adaptive query optimization, optimizer limitation versus improvement, new optimization technique, and question and answer. So proceeding for the optimizer, everyone is aware with the optimizer thing, like what happens in optimizer, what is optimizer, because optimizer is a set of programs and procedures which is provided by the Oracle itself. And here, optimizer work is to select the best possible plans, right? So we'll discuss on this introduction to optimizer. If I'm asking to tune a query, so what happens here? What optimizer used to perform here? So number one, what optimizer used to do is it will generate the explain plan. So first thing the optimizer work is, the purpose of optimizer is to generate the work plan. Then it will check if there is full table scan or not. Full table scan means what? Suppose if your table named as EMP and that EMP table is having 1 billions of records, and on 1 billions of records someone wants a record from mid value, or suppose, yeah, from the mid value, and you are doing select star from EMP. What will happen? It will fetch the records from the beginning till end if you are using this command. But what if you are using a where clause, where e name equal to Ram? So what will happen? The person with the name Ram will, if it is present in the EMP table, will be displayed, right? But say Ram is at the bottom of the 1 billion records EMP table. So what it will do, it will fetch the records from initial and it will approach the bottom of the bottom part of the table and it will throw the error, throw the output, right? So the time covered to fetch the records is what we call as a full table scan. Full table scan. And if some index is present in this table, so on that scenario, what will happen? You will be directly moved to that particular location and you will be getting the output. So suppose full table scan will uh, give you output in 2 minutes. On a similar thing, on similar command, if you have index on the particular column, you will be getting the output on within 30 seconds. So which will be the better, full table scan or index scan? Obviously it will be the index scan is better. So in case of full table scan, you have to make sure that index should be there in the table to make the query optimized and to make the query execution faster. So this is also one of the technique to tune a particular query. So you have to check whether the there is a full table scan is happening or not. If yes, then looking why index is not used. If index is there, then fine. If index is not there, then you have to check what happens to index. If index is present, yes or no. If index is not there, suppose if index is not there, then what happen? What to do? You have to create an index on particular column. There can be multiple case scenario also. Sometimes index is not usable. You can't use the index. So on that scenario, what you have to do? You have to rebuild the index online. Okay. Apart from that, we have to check the costs. It should be optimal. It will check for the better plan, the best plan, and go here and there and try few steps to improve the plans. Hope something works, but no success. So these many tasks is being assigned with the optimizer to tune a particular piece of query. So we will also let you know about the steps how we used to tune a query and how to make optimizer aware in this scenario. But as of now, you should understand that these are the functionalities, these are the things optimizer is required to tune a query. We particularly ask optimizer to perform these many things to make a query execute in a faster manner with optimal cost. Next, is there any guidelines which I can follow and my query will be tuned itself? Yes, there is a guideline. There is a particular piece of steps which you have to follow to make your query faster. So, introduction to query optimizer. There are 10 steps, which is magical steps, what we call as. To tune a particular query, we have a 10 basic steps, what we call as a magical steps. If you will follow these 10 steps, your query will be optimized very soon. So what can be the questions or what can be the issues that you will be getting from the application team? That they will say that there is a one select statement which was taking 30 seconds for its execution, but after some maintenance activities or after some changing the parameters or anything, something happens and now the query is taking 20 to 40 minutes for the execution. Obviously a query is running for 20 to 40 minutes, that is the bad, right? That is the bad part of the database. So for 20 to 40 minutes it will consume resources from the database and it will impact the other query also, because this query is because the resources which is consumed by this query will be lesser than compared to the uh, query which you are running earlier, the select one. So while running the select query, the other queries may get impacted and this leads to the degradation of the performance of the database. So the question coming to you as a DBA from the application side, that the query, that is select statement, which was taking 30 seconds for execution, but after something happens, some activity happens at the DB level or the application level, the query is taking 20 to 40 minutes to get it executed. So can you do the tune to this query? What can be done for tuning this query? So we have the simple 10 magical steps which needs to be performed. Why don't we give this task to our optimizer? Optimizer is the brain of the Oracle database. Feed optimizer and get best performance. So obviously, these many tasks is being given to the optimizer because we can't give this task. Okay, like index rebuilding or checking the full table scans and all that. We can't give the optimizer these many tasks because optimizer ultimate goal is what? To select the best possible plans. So I will let optimizer know that these are the plans and among these plans, optimizer will select the best possible plans. This task is for optimizer. So it's our responsibility to let optimizer know that the plan which is being generated are the good plans. It won't be the bad plans. Else, if there is a bad plan, then optimizer will select or optimizer will misguide it by the statistics and it will generate the bad execution plan. So always remember, it's our job to make the statistics of the tables or database objects should be updated every time so that optimizer choose the best possible plans. And as I already said that optimizer is the brain of the Oracle database. Because of this optimizer concept, Oracle is charging the huge licensing cost. And due to this only Oracle, we are paying a huge amount of money for the support also to the Oracle. Proceeding further, how optimizer works. So first of all, everyone is aware that whenever you are querying a SQL, so it is going through the parsing process, what we call as a parsing, syntax check, semantic check, and the share pool check. After that, the query is being transformed. After query transformation, estimators will estimate what are the plans that will be generated, and among the estimations and the plan hash value, collaboratively will decide the plan generator. And with the n number of plans, the final plan will be selected by the optimizer. So this is the flow which we are already aware of. Because optimizer, under optimizer only these many things will happen. First, optimizer will transform the query. Suppose if you are querying something, I will let you know about the query. Suppose if you are querying something, optimizer will transform the query into simpler format. Optimizer will transform that query into simpler format, and after transforming, what are the possible ways to get the best output that can be generated by the optimizer, and the best plan will be finally validated by the optimizer, and the query will be executed on that basis. So look, this is how a query is being transformed. Suppose you have wrote a query like select star from sales where region ID equal to 2 or prod ID equal to 11. If you are querying this thing, so it might take more time to get it executed. But to make it simpler manner, optimizer use this query to split or to transform into these sections like union all. So you don't have to worry that your query will be changed to this, then what will happen? You will get the bad data or some incomplete data. No, it's not the case. It's the responsibility of the optimizer only which transform the query, because on this aspect only optimizer is aware with the query, and from this query only they will find the n number of, they will generate the n number of plans and they will find the best possible plans. So it's not about you that you have queried this thing and now the query has been transformed to this. Both the query is same. If you will trigger this query, the second one and the first one, you will be getting the same result, but this result will be faster as compared to the query which you have triggered. Okay. If you are using subquery or unnesting, so suppose if you are used this subquery, select staff from sales where customer ID in, select customer ID from customers. So you have queried this one. Same query optimizer will transform in this. Select sales dot star from sales comma customer where this one. So you don't have to worry where from where we will get this transformations query. It will be with optimizer itself. You don't have to worry. You should be focusing on your query. If your query is wrong, then the optimizer won't be able to transform that query. So make sure you should trigger the correct query. If you are using a predicate pushing, then you can use this query also. Suppose if you are creating a view called VW as this view, so you can create a view also. If you trigger this command or you can trigger this command, the optimizer will transform that your query to this. At the end, the output will be same. Not to worry about that. But what optimizer used to do, they used to transform the query in this particular fashion. After transforming, there is a next step called estimator. What we have learned now, optimizer, the first step what optimizer used to do after parsing is transformation. After transformation, what optimizer will do? Estimator. Okay, estimator means what? Estimations. So it will check for selectivity, cardinality and cost. So on the basis of this selectivity, cardinality and cost, the best n number of plans will be generated. So at the end what happens, the cost should be minimum. Some query which cost is being higher, cardinality is low, selectivity is high. So it depends on selectivity, cardinality and cost basis. N number of plans will be generated and the best plan will be selected at the end by the optimizer itself. Once transformations and estimation will be done by the optimizer. Okay, coming to cardinality means what? Suppose there is a two value of cardinality. One is low cardinal and number two is high cardinal. High cardinal means what? You have the unique value, unique columns, and low cardinality there can be non-unique columns. Non-unique columns means what? It might be salary, it might be country or something. Or in unique column it can be ID, it can be serial number, it can be department number. So there can be multiple things. High cardinality means you have at least one primary key in that. One primary key means what? The value will be unique and number two, it will be not null. So the column which has unique value and not null value is what we call as a primary key, and that column is called high cardinal column. And a low cardinal means what? There can be a duplicate values in low cardinality. So always remember, to generate the best plan, the cardinality value should be higher. The best cardinality value we should select, because duplicate value will result in the duplicacy of the data, and you can be misguided, or optimizer can be misguided on that scenario. So it's better to have the value of high cardinal values. Okay, and the cost should be very less. Apart from that, the plan will be generated. Optimizer rule comes into effect here, and the among n number of plans, the best plan will be decided on this basis: the selectivity, cardinality, and cost. Okay, so there is the one quiz. What we call as selectivity is an internal calculations that is not visible in execution plans. So always remember, according to selectivity, cardinality, and cost, these are the three parameters, hidden parameters, on the basis of which optimizer select the best execution plan. Number one is selectivity. Number two is cardinality, and number three is cost. On these three bases, optimizer selects the best execution plans. Always remember this. And these are the hidden values or hidden parameters from which optimizer used to select a cardinal and cost they can do. Okay. Apart from that, if no statistics are available, then the optimizer either uses dynamic sampling or an internal default value. So this concept I will come later, because it's related to statistics. Once I will let you know about the gathering statistics, then I will cover about this statistics portion. Next is the cost calculation is done based on the disk IO, CPU usage, and memory usage as a unit of work. So this is also considered as a great value. According to this also, we should be knowing how cost is being calculated. So all the costing thing is being decided on the basis of disk IO, how much IO it is being utilized, how many CPUs that is present in your machines, okay, and how much CPU is being utilized by a specific query, and what about memories. So with the help of free-g, you will be able to identify the memory part, what are the total memory for a particular server, and what are the swap memory, how many memory are usable, all that. Apart from that, CPU usage. So from this command ls CPU, you will be able to identify how many CPUs are there, how many CPUs are there in your machines, and how many cores of CPUs are there in your machines. Apart from that, disk IO. So how frequently the data blocks is being fetched from data file disk to memory. So how frequently it is fetching. So some query which is repeatedly using by a user, it is fetching the suppose fetching the data block from disk to memory always. So it will do higher amount of IO. If IO is happening, that means cost is also increasing. So remember, the cost calculation is based on these three aspects: IO, CPU, and memory. Next is the cost of a query plan is the number of work unit that the same thing what I have explained just now. So remember, cost calculation is based on these three parameters. Next, cost is the measurement for the optimizer to compare the plans for the same query. Similar, you cannot tune or change the cost. So the costing you can't change. You can't change the costing during the tuning perspective. Yes, you can change the plans depending on the query or selectivity and cardinality, but you can't change the cost. Here, optimizer is smart enough. It is right. Obviously, it is very smart, because with the help of optimizer, only Oracle is charging a huge amount of money. So then why is SQL performing bad? So this is the very important scenarios in the interviews also, and these are the live scenarios which we used to get in the real life production databases. That even optimizer is there. Even optimizer has n number of parameters like they are transforming the queries, they are estimating the queries, and they are generating the number of plans. Among n number of plans, the best plan is selected on the basis of cost, selectivity, and cardinality. Then what happens? Why SQL used to perform bad? So this is the most important thing which we will discuss now. So who influences the optimizer? If optimizer is selecting the bad plan, right? If optimizer is selecting the bad plan, so ultimately what happens, the query, the uh, performance of the database will be degrading, right? So why the performance is being degraded? Due to bad SQL plans. So it might happen that optimizer is being misguided by something, then only optimizer is selecting the bad plans. Someone has threatened optimizer. So on that scenario, who influences the optimizer? So optimizer is influenced by these many things. So number one is statistics calculations. So every time remember, if the statistics of the table or data is wrong or incorrect, then optimizer will select the bad plans. So always remember, try to gather statistics every point of time. Second is depending on users also, optimizer can be misguided. Third is init parameter, the parameter files, it depends on the parameter files also. Due to some parameters, it can be impacting the optimizer to select the bad plans. There's a plan management, there's a hint, and there is a SQL profiles. With the help of SQL profiles and SQL baseline, we used to make optimizer aware that you are selecting the bad possible plans. So there can be multiple things who can influence optimizer, but the main criteria, main thing you should be knowing that statistics of the particular database objects. So always remember, try to gather the statistics of the table frequently. If there is a huge insert, update, or delete is happening to the table, so optimizer, the calculation of statistics is incorrect during that time, and optimizer is not aware that someone has done bulk deletion. So on that scenario, the statistics will be changed, and optimizer was thinking that okay, say there's a data, uh, suppose 10 lakhs data was there, and optimizer was knowing about this statistics. Someone has deleted 7 lakhs data, and optimizer is not aware that only 3 lakhs data is being present in the database. Optimizer is not aware with the statistics of the EMP table. Optimizer is knowing that okay, currently also 10 lakhs data is there, and optimizer is making the plan according to 10 lakh data. But currently how much data is present? 3 lakhs data. So obviously, if optimizer is not aware with this 3 lakhs data, it will generate the bad plan because he optimizer is thinking about the 10 lakh data is there, right? So based on the current data, we have to gather statistics. Always remember to make optimizer aware that this is the actual data. Make your decision, make your plan based on this, not on the data which was earlier in the databases. So these are the case scenarios who can influence the optimizer and who can misguide the optimizer. So controlling behavior of the optimizer, there is an init parameter are the one who controls the optimizer behavior. So these are the parameters: optimizer mode, cursor sharing. Cursor sharing is very important. We will discuss on this cursor sharing. This is important for the working perspective also, and it is important for the interview part also. There is a three type of cursor: force, exact, and similar. So we'll discuss on that. Optimizer dynamic sampling, optimizer feature enabling, index caching, cost adjective. So these are the things. I'm not sure that everything should be known to you guys, because I will share only the top 3 to 4 things because which is being used by in the market, and rest which is not used in the market. So we'll discuss on the later sections if you're interested on that. So as of now, it's of no use to learn each and every part. Moving forward with the controlling behavior of optimizer. So in 12.1, the optimizer adaptive feature was present and optimizer in memory aware parameter is being introduced. And from 12.2, these many parameters is being introduced here. So as of now, you should be knowing that what is optimizer adaptive plans, optimizer adaptive statistics, in memory aware. So these many things we will discuss in our later sections when we will generate the reports and all that. So you don't have to remember all these things. I've just given as a information to you guys that these are the parameters related to the optimizer. Okay. So the adaptive query optimization, it this is being distributed into two parts: adaptive plans and adaptive statistics. So plans is being generated, is being made with the join methods, parallel distribution methods, and bitmap indexing pruning. And the adaptive statistics, which is being distributed among dynamic statistics, automatic re-optimizations, and SQL plan directives. So under adaptive plans, suppose how a optimizer will optimize a query. So it depends on the statistics first of all, because if statistic is wrong, incorrect, then optimizer will select the bad execution plan. And if the plans is very much means if your query is pretty much good, then you have to make optimizer aware that this is my query and I want the query to be executed on the faster manner. So optimizer will transform itself in the forms of joins. The query will be transformed in the forms of joins. It will transform itself in the parallel distribution method to execute it faster manner. It will check for the bitmap index and all that. So indexing is of two types, that is bitmap and b-tree. I will let you know about the index concept also in the later sections. Coming to statistics, so there the statistics can be gathered from the dynamic sampling, automatic re-optimization, and SQL plan directives. There are certain sets of commands where we can learn these things. So yeah, how long same plan is used by optimizers? Sometimes you can say that okay, there is a plan. Suppose there is a select query, and optimizer is using plan hash value called 1234569 2. This is the plan hash value which is being running by taken by the optimizer and running for the particular piece of query. So this query, select query, was run on 22nd of May 2022 at 12 p.m. with this plan. Again, the same query is being triggered at 1 p.m. It is taking the same plan. At 3 p.m. also it is taking the same plan. Okay. So is it possible to select the same plan every time? So that is what a question is asking. How long the same plan is being used for the optimizer? So till the plan ages out from the cache or a different optimizer features invalidate the plan. That means what? Suppose if your statistics is changed, okay, statistics of the table is being changed, and optimizer is being aware with the statistics now. So on that scenario, the best plan will be decided. The best plan will be decided by the optimizer, right? Then on that basis, the optimizer will select the different plan hash value. This time 3, 4, 5, 6, 7, 9, 2, 3, like this. So it depends on the statistics of the table. If the table statistics is being changing, the optimizer will select the plans according to the statistics. Okay, and the plan can age out if the statistics is being changed. On a simpler manner, always remember related to the statistics. One question from my end also. What happens if you want to, if suppose there is two plans, 1, 2, 3, 4, 5, and there is different plan 3, 2, 6. Okay. On the first plan, the IO is being suppose 1450, and in this plan, IO was taking 5392. Obviously, the IO is 5392 is much more higher than IO in 1450. This is the plan hash value. if optimizer is selecting this plan, it is taking the hell amount of execution time to get it executed. It is taking a hell amount of IO, right? So what we have to do, we have to make optimizer aware that okay, you are selecting the plan which you are selecting is very bad. Please select this possible plans. So how to make aware that optimizer that you have to select this plan? We can create a profile, or sorry, SQL profile or SQL baseline, to make optimizer aware that this is the best possible plan. Try to run the query from this plan only. Okay, so we can keep it up to here and try to go through the optimizer sections, and we will do the practicals in the coming session, but as of now you should know about the theoretical part. So thank you everyone, take care, bye bye.